for joining today. I'm really excited to talk about the work that we've been doing with Inferno and testing around FHIR APIs. My name is Rob Scanlon. I'm a principal software engineer at MITRE and the Inferno project leader. I've been working in sort of the FHIR testing space for a good 4 or 5 years now. Previously, I was the co-PI, co-principal investigator of a project called Reusable, which is still around, where we were doing a lot of work testing sort of broadly FHIR servers. Inferno is a little bit of a follow-up to that has a little bit of a different focus, and I'll talk a little bit about that. But I am I'm a software engineer sort of by trade. I've been doing it for about 20 years, building APIs and building sort of web apps and whatnot for quite a while. So today I'm going to talk about the work we're doing on Inferno. These talks are usually pretty challenging for me to sort of figure out exactly what I should focus on, because a lot of times it seems like people are either really interested in ONC certification criteria and the requirements around testing for that, which can get pretty in-depth, and there's sort of a whole bunch of details around that. And then there's sort of another group of people that are really interested in how they might be able to reuse some of the work that we've done here to build tests out for other implementation guides. So, what sort of pieces are reusable about Inferno. I think what I'm doing in this talk, I'm gonna sort of cover both at, I guess, sort of a medium level. Hopefully, that's okay. But the good news is I'll be around, happy to dive more into this with anybody that's interested later this week or really sort of whenever. So that's my plan. I'm going to try to have this go about 40 minutes or 35 minutes to leave a little bit of time at the end for questions and answers as well. But hopefully I can make that happen. So let's see. All right. So just to give everybody, sort of level set everybody, if you haven't heard of Inferno, it's an open source FHIR API testing framework. So it's focused on server testing, so testing the actual APIs versus the clients that might be consuming those APIs. It's also focused on implementation guide testing. So really, it's designed so you need to write tests specifically for the implementation guide that you're interested in testing. I'll talk about some of the tests, some of the implementation guides we've already written tests for. But it's the type of thing where if you have an implementation guide that you'd like to use maybe Inferno to test against, you'll have to do a little bit of work writing tests in the environment. This work is being funded by the Office of the National Coordinator for Health IT, and an initiative was created to test ONC Standardized API certification criteria. So if you're not from the US or you're not familiar with ONC's certification program, you really there's if you're sort of creating EHR sort of like software in the US, you want to be part of the incentive programs associated with CMS, you need to get certified by ONC and their criteria. And one of the criteria, I knew this fairly recently, requires a standardized API, which specifically is a FHIR API. So ONC funded us to write this set of tests as sort of because they wanted to have a set of tests about when the rule was announced, so that people could start testing and basically see exactly what the requirements of the API of the API are based on the test. So that's why we're a part of that. And this is being developed and maintained by MITRE, but it is all open source. We're happy to accept contributions. I'll show you guys the GitHub repositories. But just about everything up to this point has been developed by my team at MITRE. So what does Inferno kind of provide you at a high level? It's a testing framework. It's really focused on providing a flexible test execution environment with some easy FHIR bindings. So we basically provide you a fully functioning programming language, Ruby specifically, and add a bunch of tools around that to make it easy to do things in FHIR. So the nice thing about that is you can really write tests however you want, and you can sort of leverage the full power of a programming language if there's a lot of repetition or things like that in your tests themselves. We provide a FHIR client, a FHIR validator, a terminology validator, assertion library. We also really were focused on making this very easy for people to use. So if you'd like to run the tests against your own implementation, you obviously didn't write the tests, but we want to make it easy enough and provide enough sort of context so that if something goes wrong, we provide as much information as possible to let you know what went wrong. So it does have a web interface. We also have a command line interface that you can use to integrate into like a CI kind of pipeline if you'd like to do that. Another thing about this is that it is it's completely downloadable. You can run it locally on your own machine or on a shared server. We didn't want this to be something that had to be a service that ONC maintained kind of sort of indefinitely in order for it to be usable. We also didn't want it to be something where you would have to poke holes in your firewall in order to test against. So we've sort of packaged this all up so you can download it and run it locally. Now I mentioned before that kind of how Inferno works. It's sort of a framework where you have to write tests. We have written tests for a number of implementation guides. To start, we wrote a whole bunch of tests around ONC Standardized API for patient population services. We generally refer to that as the program edition. That's kind of like a super implementation guide that requires a number of other implementation guides and also has a number of other requirements as part of it. So essentially you have one sort of spot to go for all the testing around ONC certification. But then also separately, you can go and test different implementation guides individually. So the Smart App Launch Guide, we have tests around that. US Core, you can go into that individually. Smart Bulk Data, Smart Scheduling Links, that's a newer one that we've been working on, and International Patient Summary. So if you go onto our website, you can sort of navigate around and find those tests. There have been a number of other people that have been playing around with Inferno outside of our team as well, but I don't have any sort of links to those right now. So kind of go back. Now that sort of given sort of a brief overview of Inferno in general, I'm going to go and talk a bit about the actual the ONC Standardized API for patient and population services criterion tests. So these are the tests that we wrote using Inferno. I'm going to walk through those. So if you're interested in that certification criteria and what's required and how to test against that, this will be useful. I'm also going to use it just as sort of an example of how tests are represented in Inferno. Very briefly, ONC, they put out a rule. There was a proposed rule a couple of years ago, and the final rule fairly recently that will require certified health IT that gets certified through them to support a standards-based API, and they point to the FHIR specification. So it will be a requirement for systems in the US to support a FHIR interface. And the sort of the use case that they're really targeting has to do with patient data access. So the data is all about the kind of the patient medical record, and so the API use cases are primarily around patients using apps to access their data, or third-party apps that can get embedded in a practitioner's workflow. And there's also a use case around shipping large quantities of standardized data over the bulk interface. So the standards involved really. So obviously there's FHIR and a number of implementation guides. So there's a US Core Implementation Guide, release 311. So that provides the standardized, so the profile requirements in the US around basically a kind of basic patient medical record. I believe there was a talk earlier today on US Core and the Argonaut group and that sort of the work they're doing there and where they stand. But that is a requirement. So it requires it defines the data, and then also a query, a RESTful API that's really targeted at sort of transmitting small numbers of patient medical records at any given time. So it's so more suitable for like patient apps that might be looking at one or sort of a handful of patients at a time, not thousands or millions. However, for those kind of larger use cases with a lot more data, there is also the requirement on the API side for the bulk data access IG SDU1. So you need that as well. On the so besides just defining the API and the data model, in order to have kind of an end-to-end useful, sort of ensure that everything kind of can be standardized for the sort of app use case and the bulk data use case, you also need to define an authorization framework, and that's where the smart set of some of the smart implementation guides come into play. So the smart app launch framework defines how to authorize and enable essentially third-party apps and services. And as well as there's also the system authorization using the smart backend services. That's part of that implementation guide. And then besides those two, there's a kind of a whole bunch of kind of glue requirements that ONC put in to make sure that the use cases that they really wanted to enable were required in some way. So there are a handful of other requirements. So for example, you need to support token refresh, and there's an expiration time associated with that. So another number of other standards. So our set of tests for this take into account all these different pieces, and how we go about testing it is we essentially act as a very demanding single patient and multi-patient client application. We test the full integrated authorization and data access, so we don't just test things separately. We actually focus more on testing the combination of these different capabilities can work together. We in general, we avoid testing capabilities multiple times. So because we have this sort of end-to-end approach, we don't test every combination of every capability that you might want. We focus on making sure that every capability is tested at least once, but then we also provide a number of sort of tests to make sure that useful sort of specific use cases work. So like a standalone patient application, like a mobile app can work all the way through from authorization and all the way down to sending data. We also provide an interface to log visual inspection or attestation when automated testing isn't possible. So we wanted to cover all of the requirements, even if they're not automated. So we have a step at the very end that basically points out all of the gaps that we just simply can't test because they're not automated, or it just turned out they're just too difficult to test. But we want to make sure that we at least highlight those and provide an interface to basically have the tester check off that that you have to do it. So how that works out, essentially we have 5 high-level scenarios, 51 what we call sequences. These are kind of like the main tests. Within those, we have 300 individual tests. And when you walk through this, a typical testing session with sort of an average set of data performs thousands of HTTP requests. The one other piece that about our approach here that might be a little unique or different is that servers can provide their own complete test data when they're under test. So I know a lot of test procedures involve a specific set of test data that you need to preload. Instead of doing that, we leverage FHIR's built-in conformance rules to make sure that all the data is correct and consistent. And then we, from a completeness perspective, we basically make sure that all the must support data elements have been provided at least once, so that we know that they are capable of sending that information. The nice thing about this is that we found when we were putting together test data sets, there's a lot of flexibility in what a given system may or may not implement, and so it's very difficult to have sort of one set of test data that everyone can support. So instead, we have it set up so that you can bring your own data. So I'm just going to hop over and quickly walk through those set of tests as kind of an example of how this looks within Inferno itself. Hopefully, let's see. It's always a risk with live demos, but we'll give it a shot. So if you go to inferno.healthit.gov, you can see we've sort of broken these up into 2 editions. I'm going through the set of tests specifically for ONC certification criteria, and so that lives by itself on the left side. All the other tests that I talked about live in the community, what we call the community edition side over here. So I'm just going to hop in here. Inferno, we try to make it really easy to get started, so we don't have logins or you don't have to sign up or anything like that. You basically just put a FHIR endpoint in to get started. You can also choose a sort of a set of presets. So I'm going to choose we have a fully conformant API that we can test against, so you can sort of see all the tests running if you choose that. I'm just going to go ahead and click Start Testing, and this is the main interface for Inferno. Really, the idea here is you just you progress from left to right. It's kind of like a wizard. Along the top are the main scenarios that you have to demonstrate. Each one of the scenarios, there's some context that we sort of provide that describe what we're trying to do, and anything you have to set up ahead of time. And so for this first scenario, I'll just kind of go ahead and run it. It's to demonstrate that your system can support a standalone patient app. And you can, before you run it, you can take a look to see what specifically we're going to test. So this involves smart FHIR discovery. We're going to do a standalone launch with patient level scope. That's what we're requiring. We require OpenID Connect, token refresh, and we're going to require a bearer token return that provides unrestricted resource access, read resource access to all of the required resources in US Core and US CDI. So you click Run. You provide a whole bunch of input fields. These are pre-filled based on the reference server that we're using. However, usually you would go and register Inferno as a smart app and get a confidential client and a client ID and a client secret. You have some flexibility in how scopes are represented. So you can put in patient/star.read, for example. But once you put all that in, you click Execute. And now we're running the test. Now, what's a little complicated about the smart app launch set of tests is that we require a browser, basically the tester's browser, to be redirected away from Inferno into the system under test. It's just sort of part of the app flow or OAuth flow. So I'm going to go ahead and do that. We got redirected away to our own like little demo server that we're testing. This is a patient picker. So in this scenario, we sort of decided on a reference server that this user would have access to multiple patients, but we need to choose just one. So I'm just going to choose one of them. Here's a very basic sort of authorization screen. I would expect many real systems to have something that looks quite a bit nicer, but then we just click Authorize. Now we're getting redirected back to Inferno, and the test's complete. And so now you can see that all the tests passed. In this case, you can drill in to any given test, and you can see all the different steps involved. You can see any of the requests that were made and any of the responses. So, for example, this is the very first one here is a request to the well-known endpoint. Click on results, you can see the request that was made in response. So, I think these are the types of things that most people would expect of a test system. Nothing too exciting here, but one of the things we did try to do is if everything's working well, that's there's nothing too exciting here. What we did try to do though is put a lot of metadata and extra information in it to describe what we're doing and any of the failures. If there are any failures, we try to provide descriptive failure case. What I'll do is I'll quickly rerun this and show what a failure might look like. I'll just go ahead and do this. And what I'm going to do this time is I'm just going to uncheck a required something that Inferno is requiring to be granted the FHIR user scope. And when you click authorize here, what should happen this time is a failure should come up. And it does under the standalone launch, specifically step 10 here, the patient level access with OpenID Connect and refresh token scopes used. One of the scopes wasn't received, and that's FHIR user. So that's the one that I unchecked. So that's basically how the user interface looks. In order to do all the tests, you would just click through from left to right. The one a little bit of a special case is this sort of other section. So we have these 5 scenarios which cut across most of the required capabilities. There are a handful of requirements that we could not test that just aren't ever tested in these scenarios. And so in this case, we decided when we built our tests out to put them all in the sort of other section. So this is where we're checking things like token revocation, a couple of important tests around invalid parameters getting passed and making sure the system properly rejects it. And then finally, the very last step, I had mentioned that we provide a sort of a survey that lets you, that lets the tester basically gives them a spot to register whether or not they actually did everything that is required, even the things that are not automated within Inferno. So this is sort of just a kind of a nice way to ensure that within one test tool we have complete test coverage of all the requirements, even if some of them aren't things that Inferno can do internally. So so that's a quick overview of Inferno. Let me hop back over. And hold on 1 second. Let's check to make sure. Good. All right. Over here. And I'm just going to make sure that it's still good. Okay. So hopping back to the slide deck here, I'm going to so that's just kind of very briefly how you would execute a number of tests against against ONC certification criteria and the requirements about that. I'm just going to sort of shift gears a bit and discuss so how those tests are put together. So for people that might be interested in reusing some of the pieces that I've shown, we can do that. Over here. Okay. So how does Inferno? So like, what's our general, I guess, test design approach? So as I mentioned, Inferno uses a Ruby-based DSL. So you have a full access to a programming language. Ruby's pretty frequently used in sort of testing kind of circles and infrastructure circles, and also to create DSLs because it's pretty easy to do. So we basically provide that. We also have a way to so you basically write your tests with a certain number of inputs and outputs and configuration options. And then we have a way to organize and orchestrate those different tests together. So you can write one test. So for example, like a smart app launch test, and that can optionally either test a public client or a confidential client, and then set it up so that you write that test once, but then require in different contexts. So a system can be required to demonstrate support for both confidential clients and non-confidential clients, or one or the other, right, or both. So instead of having to sort of write the test twice, you can basically sort of create multiple instances of them based on different sort of configurations. We also provide, I sort of broadly call them patterns, because we, I think there's still some work to do here on figuring out exactly how to handle some of this stuff, but we provide patterns to generate tests based on some of the structured data that comes in implementation guides. So for example, in US Core, our tests are actually written in such a way so that they look at the capability statements, and then the tests themselves are actually generated based on the capability statement. And I'll quickly go through what that looks like. And then also we have general pattern for testing your own tests. So a big, I think a big downside to our approach here, which is using a full imperative programming language. If you start doing anything too complex, you really should start testing your own tests to make sure that you're doing things correctly and that all sort of edge cases are avoided. One of the nice things about using something like the test script resource that other test tools such as Touchstone use is that you don't really have to do that, because you basically can inspect the test script and see that it you can see exactly what it does, right? Versus some of our tests have some complicated logic in them. And therefore we like to write tests for our own tests, but we provide patterns to do that. So the Inferno DSL, just sort of briefly to give a quick overview of what that looks like. It's an executable testing code written in Ruby. As I mentioned before, it provides FHIR client, FHIR resource, /profile validator. You can do passes and fails and sort of various flavors. So we've also defined a couple of other statuses like omit, which is passing, but only because you don't, not because you actually do the capability, but because you don't have to, or you sort of opted out in some way. We also have a skip flag, which is for cases when you haven't necessarily done, a system hasn't done anything wrong necessarily, but they haven't done enough to demonstrate that they pass. So oftentimes for some like our must support data checking, if they sent back all valid resources, but they just haven't sent back all elements that we're looking for, we'll provide a skip and then state, hey, please also provide this extra information. And we have things like warnings as well for requirements that are like sort of should requirements. We also kind of optimize this so that there's a lot of room for metadata and a place to sort of write out what tests do in a human readable form. So we found just through practice that it's that if something breaks, you really need to describe what exactly you're doing and everything that you're covering. To give some context for the person testing and the system to sort of figure out what this error means and what sort of context. So we provide a lot of space for that. So on sort of on the right side here, I put some code that has one of the tests that we ran through the Smart on FHIR Discovery set of tests. And so really the first page or so is on sort of that kind of metadata details describing exactly what the test does and the test name, and then also what inputs there are and outputs there are on the test. So it inputs a URL, it requires a URL basically to run, but then it also will save off some information that it comes along the way that other tests can then use as inputs. So the sort of on the right side, that code it ends up looking like this on the right side in the interface itself. So there are 6 steps, so for example, that about tab on the right side is where all that information at the top of the test that you saw on the previous screen shows up. So briefly, the general idea is that you write reusable tests that are configurable with various inputs that can potentially change the behavior of the test. But then what you can do is then when you put together a sort of a test procedure, you can string those together and execute them in sort of different contexts. So you can, as I mentioned before, you can run a smart app launch in that requires demonstration of a confidential client, and separately, without writing any more code, you can run the same. You can require running the same test as a public client. The other thing we do is we provide some pretty basic input and output chaining. So that discovery sequence that we saw previously, it will grab some information from the well-known endpoint, which then can be used automatically in the launch sequence so that the user doesn't have to input that information. We also provide the ability to lock certain inputs to certain things. So in this case, we require the use of a confidential client. And so we basically lock that to what the default is. So we provide, we found it very useful to have this layer as well. And just to take a quick look at what that looks like in the interface itself, that's just the configuration for that first tab where we have that Smart on FHIR discovery, which is followed by the standalone launch, and then OpenID Connect and token refresh. And so this sort of enables a certain amount of reuse. One of the things that's nice about this is that what you can do is you can have one group can write a comprehensive set of tests for something like the Smart App Launch Guide, and then you can reuse them in another test suite that you're creating, right? So you don't necessarily, you basically can import in those tests and sort of provide the configuration that you want, whether it's, you might require confidential clients or not, or whatever, right? So you can basically just import those and define them without having to write any more tests around that. And finally, the one other piece that I'd like to go over is test generation. So Ruby's a pretty flexible language where you can kind of do all this meta programming if you want, and define tests sort of executably on the fly by reading metadata. What we do instead is, in all of the tests that we've written so far, is we have a test generation step ahead of time, which basically ingests an IG and outputs tests. So we look at the capability statements, the profiles, search parameters, and we rely on a number of computable extensions to things like capability statement in order to determine basically what tests to write. And so we've written tests. We basically written code to write tests around the basic RESTful interactions that may be required by a FHIR server. And so when you're getting started, you can just go ahead and try out those generators based on the IG that you're working on. If you provide a capability statement that is explicit about the requirements in that way, and so it sort of gives you a starting point. So then you get basically all these tests pre-written, and then you can hop in and add more tests, or you can change them or tweak them if you'd like. And really quickly, just sort of demonstrate what that looks like. On the left, we have a profile that's in US core interaction. Excuse me. We have the capability statement. The capability statement for the US core server, which provides basically a list of the profiles that they need to support and the different interactions. And we use that to generate the test. So just kind of going through here the different pieces, which actually are used by US Core to generate the actual implementation guide sort of narrative that you read. It uses this as well to generate that, and so we use that to generate our tests. And so if you kind of hop down and see what that outputs, here's the allergy intolerance a set of tests that get automatically generated, and you can see we've pulled in all of the required search parameters and search combinations, and whether or not they're optional. And if you need read, v-read history, and we basically written out we have a pretty generic sort of set of tests that that work kind of in this fashion. Now, the one caveat here is that this test generator is very much written had certain assumptions about an implementation guide and sort of the types of interactions, that it requires searching and reading in order for it to basically be able to function. But the general idea here is that I think we'll start working on building out various generators based on sort of the different type of popular interactions that sort of, I guess, patterns associated with sort of FHIR APIs, so that if it doesn't fit sort of in this is almost like a patient sort of crawl kind of sort of pattern, you can use that other generator. So looking forward, and I think I just have a couple minutes left. So we are the history of the project. We really were focused on building out ONC certification tests first. So that was the initial priority. We tried to make things sort of as reusable as possible. But what we're doing now is we are circling back and sort of any of the, as we've gotten more experience with different implementation guides and what sort of different testing is needed, we're circling back and essentially refactoring Inferno. We're looking at improving the DSL to make it a little bit easier to use and a little bit more self-explanatory. Also working on documentation around that so people outside of our team can use it more easily. Another big focus is just simplifying the process for creating and reusing test suites. So right now, you need to fork the Inferno project and add some tests. That isn't great for sharing test suites, and there are a number of sort of steps involved. We're looking really hard at how to make it so that you can start from sort of scratch and build out tests without too much work. We're also, looking at standardizing some of the internal and external interfaces. So we do integrate with HL7's FHIR validator as one option for a validator. We're looking to standardize some of the pieces, also standardizing the API for terminology validation. And also something I really would like to do is integrate a FHIR test script resource runner. We didn't initially do that because it didn't meet our requirements. Specifically around testing the Smart App Launch Guide, but I think there are a lot of benefits to using the test script resource for testing, and we do have a test script execution engine in Reusable that we can pull in. So hopefully we'll be able to get that in and just provide another. So you can either test with Inferno's DSL, or you can sort of pass in a test script to ingest. So that's broadly what we're looking at working on. Don't have a lot of time. I just wanted to bring up a couple of the things that we found to be particularly challenging. And there are a lot of words up here, and we don't have a lot of time to go through it. But I think I think my main point here is that testing FHIR APIs can be a bit more difficult than you might expect, just because of the optionality in FHIR and how many different sort of I guess ways that you can use FHIR, which is great, but it makes testing a little hard, because there are plenty of times when we write tests and we took for granted certain things were required of a system, but turns out they're not, because FHIR is flexible. So it makes it difficult to test. And also, I think there really is a very there's a big limit on what can be automated. when you're talking about testing FHIR, I think a lot of times we focus on some of the structural aspects of the API when we talk about the API, when we talk about testing. But sort of a big part of it is the data that gets sent over the wire must actually mean what was intended, and the only really way of doing that is to have a human in the loop. So I think if you want to be very thorough about testing, you have to be realistic about how much effort is necessary in order to make sure that a system does everything that is required. Another big area for us was we have to test multiple standards and where they overlap. A lot of times the requirements become very fuzzy and gray, and we've had to do a lot of work to sort of making sure that that any of those sort of overlapping spots would be addressed. And finally, implementation guides, they can be very complex. They can impose really just about any constraint you could think of. US Core has a lot of them that were requirements for the systems that they wanted to apply this to, which makes sense, but just something to sort of be mindful of, that in order to build test systems for implementation guides, it's a good idea to have some way of testing any of these more difficult constraints. And with that, I think I only have about 2 minutes. I'll just leave up, I guess, 1 minute. So not a lot of time for Q&A. And I think what I might end up doing is let me check to see if there are any two questions. So I think what I'll do is just take this minute to answer these two questions in Whova, and please feel free to add. I think what we'll do is just please feel free to ask questions via Whova, and over the next day or two, I'll go back and make sure I answer all of them. So just this first one, there was a question about Crucible and how we can run test script resource. At the very end here, I did mention that we would like to integrate the test script runner from Crucible, because I do think there's definite value to that approach as one option. And then the other questions, can you elaborate a bit more about the Community Edition versus the ONC Program Edition? And this is a point of, I think, confusion. Sort of broadly, naming things is hard, right? So in general, the idea is that when we say ONC Program Edition, those are the set of tests for the ONC certification criteria. It's basically its own standalone thing. We manage it separately currently, and then everything else, all the other tests we write, fall under the Community Edition umbrella, and that includes sort of the reusable portion. So you can think of the Program Edition as essentially a standalone fork that you can download and run, and be very, very, very stable. And the Community Edition will be a little bit more apt to change over time. So I think with that, I am out of time, and I apologize for not leaving more time for questions at the end. But I really appreciate everybody attending, and I look forward to talking to you all in the near future.
Thank you, Rob, for that wonderful session. And thanks for sharing your knowledge with us today. And thank you to our attendees for joining us. We would appreciate it if you have a moment to rate the session in Whova by clicking on the link in the session information. And thanks once again for joining us today. And that concludes today's session.
Thank you.
Thank you.